Okay, welcome back. This is next one, the training 33. So this time we're going to look at the new aided question from USACO section 1.3 called ski course design. Let's see the question. Yes. Okay, ski course design. Farmer John is, well, fabulous person. Farmer John has N house on his farm. I don't know how large his farm is, but he has N house, and this region can go from 1 to 1,000. So yeah, each with the integer elevation in a range 0 to 100. In the winter, since there is abundant snow on the hills, FJ routinely operate a ski training camp. Okay, basically, Farmer John faced a trap. This trap is from the new tax. Is from the new tax. Whatever they call it, will be assessed next year on the farm used as a ski training camps. I don't know why. What kind of country will have this policy for a ski training camp? Well, he found out he don't have to pay the tax if his highest and lowest hill on his property to be strictly larger than 17. So he, okay, actually it's reversed. So after tax, as long as the new difference between the highest and lowest hill as most 17. So FJ has to modify, not modify, it has to fix his hills so he can avoid paying the tax. If it costs X square units of money to change the highest hill by X units, what is the minimal amount of money FJ would need to pay? Alright, so that means if he has a hill like the height is 24, he want to fix it to a 20, so he can actually make it like a he need to change the height of hill by 4 units, because 20 and 24 and 20, that is 4, so he need to cost like 16 square. So 4 square, 4 times 4 is 16. FJ is only willing to change the height of each hill by integer amount. That means there will be 0.5, 0.2, no, nothing like that. Okay, the first line, easy, integer n is 5. It's 5. And each line contains a elevation of a single hill. So let's see how we have 5, we have 24, 1, 24, and 21. Obviously, the input is not in order, and the output is 18. Output is 18. 18 is come from FJ keeps the hill height 4, 20, and 21. 4, 20, and 21 not moving. He adds the mass to height of the height hill of height 1, bring it to height 4 cos 3, or 4, 1 cos 3, to 3 square is 9. He shortened the hill of 24 to 21, so 3 square 9, 9 plus 9 is 18. So as easy as that. Okay, let's see the code to make the algorithm work. Let's see. Yes. Okay. As we know, this is not ordered. It's not ordered. So, well, I introduce you the input first. First is n cases. Second, from 0 to n, I++, C in AI. IA is the array to keep track of the height of the hill. Here, first, you need to sort it first. Because it's not in order, it's very hard to modify them if we don't have them in order, because we always want to know what is the highest hill, what is the lowest hill, and max because we want to find the minimum cost, and S here is a temporary temporary cost. Okay, the outer loop is from A0 to AN-1. This is the highest hill in the input data. This is the lowest. And why we want to do that? We want to do that is because we want to scan through this range. So, before I need to mention about the data range. Data range is the height of hill is between 0 to 100. So at most, this loop is 100. We don't facing any large problems. So this I is the expected lowest height. So we assume now I is the lowest. So I need to keep all the hills either equals to I, either is not exceed I plus 17. So I scan through all the hills. J is smaller than I, that means he's even smaller. So we need to bring it up. So S will plus I minus AI, the difference, plus times I minus A. So it's I minus AJ's, it's AJ, sorry. It's AJ's square. So this is the cost of fixing lower mountain, hill, sorry. Else, because between I and I plus 17, the hill doesn't need to be fixed. But between them, but over than that, you need to fix. So if AJ minus 17 is larger than I, so we need to fix that to some range. So we also have AJ minus 17 minus I times AJ minus 17 minus I, and S will plus that. And if S is smaller than sum, the sum will equal to S. But we scan through, so we consider all the possibilities. It's working very well. So, and then we see out the sum. Let me try to submit this for another time, maybe. Let's see. Okay, choose file, ski design. I want to know if there are quizy data. Actually, not so many quizy data. The third one is 100. The fourth one is 200. Let's see, that goes straight to 6 is 17, 700. 700, I guess is 800. 900. Finally, yeah, finally is 1,000. The larger case is 1,000. No surprise. But our time for test 10 is only 0.008. Effective, because we don't have a lot of cases. At most, we are dealing with 100 times 1,000. So that is 100,000. So I guess that is almost it. I will see you next time. Thanks.